All right. Welcome to video 2 of chapter 5.3 in our book. Quick reminder on vocabulary in case you haven't seen it in a while. Anytime you have a curve, there is a cave side. And we call this the concave side. The other side we call the convex side. But honestly, the general standard is to just refer to everything by which direction it is concave. Either concave up, which means pointed that way, or concave down, which means pointed that way. Just makes life easier that every time you're thinking about a description, you don't have to first sort out concave versus convex before you think about direction. So let's talk about concavity. Well, let's think about this graph. Here is a graph that is concave up. And notice that the slope of the tangent line is increasing. The first derivative is increasing. Well, what that tells me is that the slope of the slope must be positive. The second derivative greater than 0, we have a function that is concave up. Let's look at concave down. There's a tangent line, and a little bit later on, there's a tangent line. Notice the slope of this curve is decreasing. Well, if the slope is decreasing, then the slope of the slope must be negative. So our second derivative tells us that if the second derivative is greater than 0, my function is concave up. And if my second derivative is less than 0, my function is concave down. Again, in your notes, strongly recommend that you jot that down because we're going to be using that fact a lot. So let's talk about what we do with this. Example 2. Y equals x squared on the interval 3, 10. Now, obviously, I think you can already know the answer. The answer is that this function is concave up because quadratics are concave up everywhere. But let's use the second derivative test. First derivative, y equals 2x using the power rule. Second derivative, y double prime equals 2 using the constant multiplier rule and the power rule. Oh, the second derivative is greater than 0 on the interval 3, 10, as it is on every other interval on this function. Therefore, y equals x squared is concave up on the interval. Okay, well, that was a pretty easy one. Let's call that question A. Let's do a different one. Y equals 3 plus sine of x on the interval 0 to 2 pi. Concave up or concave down? Well, we can already sort of visualize that here's our function. There's the interval 0 to 2 pi. So we expect concave down over here. We expect concave up over here. Let's see what we get. The first derivative is, well, the derivative of sine is cosine. The derivative of 3 is 0. The second derivative is negative sine of x. And so now the question is, when is it less than 0? When is it more than 0? Well, we can look at the graph of y equals sine of x in order to tell. And we can see, this is pi and this is 2 pi, that negative sine of x is less than 0 in the interval 0 to pi, and negative sine of x is greater than 0 in the interval pi to 2 pi. Well, less than 0 implies concave down, y prime, double prime, excuse me, less than 0, 0 to pi, which implies concave down, and y double prime greater than 0 in the interval pi to 2 pi, which implies concave up. And that is exactly what we expected when we were originally looking at the graph of y equals 3 plus sine. Well, we were looking at the graph of sine of x. Remember, shifted up 3 doesn't affect the concavity. So here's one little reminder. Don't forget you are looking for the concavity of y, not y double prime. And why do I mention that? Well, if I get to the point in this problem where y double prime equals negative sine x, I might think to myself, well, let's just quickly graph y equals negative sine of x. And I would say, aha, concave up, concave down. Because in the process of taking all my derivatives, I forgot that I'm not interested in the concavity of the second derivative. I'm interested in the value of the second derivative. Y double prime less than 0, y double prime greater than 0. Therefore, concavity of y. All right, so that's just a quick reminder so we don't get confused with all the different graphs and equations floating around. And let's see, I did not jot down a problem for my students to do, but now I remember I want them to do exercise 8. And we'll be back with the next video where we'll talk about inflection points. All right, thanks for watching.